Okay. Last class we did solving a system of linear equations graphically. Today we're going to do it algebraically. And we're actually going to be looking at two techniques. One is called the substitution. One is actually called the elimination method or the addition method. I used to call it elimination by addition. Now everyone calls it the addition method. So let's look at substitution. Substitution method. I'll write the steps for them. The first step, what you want to do is actually solve for one of the variable in either equation. So solve one equation for one of the variables, one of the unknowns or the variables, whatever you want to call it. Top equation, bottom equation, doesn't matter. And whatever answer you come up with, whatever value for that variable you come up with, what you want to do is substitute the solution that you came up with in step number one into the other. Now they can't use the same equation. The other equation. And when you substitute, what's going to happen if you have two equations by two unknowns, you end up actually with one equation by one unknown. So step number three, you want to solve the resulting equation. And step number four, when you're done, check your answers. Check the values or the solution in both equations, not one, both. And you really want to go original equation. Check them on the original equations. Because sometimes if you make a mistake, the solution might be okay for the mistake that you made, but if you plug them into the original one, it doesn't work. So those are the steps I'm going to use. 4 steps. So let's take an example. And I'll keep flashing this sheet of paper back and forth. Let's say I have x minus 3y equals 6, and the other one 2x plus 3y equals 3. And the question, solve by substitution. We want to use the substitution method. In this example, the substitution method is not the best way to do it. It's really the addition method is better. But I want to enforce the substitution method. It says solve one equation for one of the variables. It doesn't matter which one, the top, the bottom, doesn't matter. X and Y, it doesn't matter. The easiest one to solve for is what? Which variable in which equation? X in which one? The top one, absolutely. If you solve for x in the top one, you will have what? X equals 3y plus 6. Notice you move the minus 3y to that side. The reason it's better to solve for x because if you solve for y, what are you going to have? you got to divide by 3 or negative 3, and you're going to be dealing with the fractions. And nobody wants to deal with the fractions unless you have to. So solve one of the equations, or one equations for one of the variables. We did that. Substitute the solution into the other equation. So that value there, here's my other equation, that's this one. 2 times, in place of x, I'm going to replace x now with what? 3y plus 6. Substitute that value. Substitute in the other equation, this is my other equation, the value of x by 3y plus 6. And step number 3, solve the resulting equation. Now solve that one. 2 times 3y is what? 6y plus 12 plus 3y equals to 3. 6y plus 3y is what? 9y plus 12 equals 3. Now to solve for y, we need to take the 12 to the other side, turn it to what? Negative 12? Change side, change sign. So 9y equals what? Negative 9. Do you agree with that, negative 9? What's y equal to? Negative 1. If I know y, can I find x? X equals 3 times a negative 1 plus the 6. That's a negative 3 plus 6, which is what? 3. So my solution, if I was to graph this, they will intersect as 3 comma negative 1. And now the next step is, the last step is check the solution in both original equations. See if they work. Let's check them. I'll use red color to check them. So I'm going to check the solution. X is 3, y is negative 1. Is 3 minus 3 times a negative 1, does that equal to 6? Is 3 plus 3, does that equal to 6? Yes, the first equation is good. Let's try the other equation. 2 times 3 plus 3 times a negative 1, does that equal to 3? 6 minus 3, is that equal to 3? Yes, it's yes in both. That is my solution. So my solution, 3 comma negative 1, is good. That's how the substitution works. We solve for one of the variables in either equation, plug it into the other equation, solve, check your answer. 4 steps. Let's try another one. I have 3x minus 2y equals 4. X plus 3y equals 2. Again, we need to solve for one of the variables. What do you want to solve for? Which one the easiest one to solve for? In which equation? Bottom one for x. Sure. X equals what? 2 minus the 3y. Now go to the other equation, which happens to be the top one, and replace x now with 2 minus 3y. Minus the 2y is equal to 4. Let's solve this one. 3 times 2, 6 minus what? 9y minus 2y is equal to 4. 6 minus what? 11y is 4. Move the 6 there, becomes a negative 6. 4 minus 6 is what? Negative 2. What is y equal to? Negative over negative, that's positive 211. Bless you. Now can I solve for x? Let's grab this one. 2 minus 3 times 211. 2 minus 6 over 11. Again, that's over 1. Your LCD is 11. 2 times 11 is 22 minus the 6. What's 22 minus 6? Is it 16? So my solution, x is what? X is always first, 16 over 11, and the y value 2 over 11. There is no way on earth I could have done this graphically and came up with these two values. No way. Again, you need to check your answers. I'm lazy. I really don't check my answers that often, especially when it's a fraction like this, like, oh, forget it. But, and the reason I say that, because I got 15, well, can be 15, even number, 16, 18 eyes watching me. So if I make a mistake, and let me know. But if you're doing it by yourself and nobody's looking at it, you want to make sure you got it right. Check your solution. So 3 times x, x is what? 16 over 11 minus 2 times 11, y, which is 2 over 11. Does that equal to 4? That's a 48. 11 minus 4 over 11. Does it equal to 4? What's 48 minus 4? 44 over 11. Is that equal to 4? Yes. Check the second equation, original one. Go to this one. X, which is what? 16 over 11 plus 3 times y. Y is what? 2 over 11. Does that equal to, question mark, does it equal to 2? 16 plus 611, does it equal to 2? 22 over 11, is that a 2? Yes, it is. So I did it right. Notice the answer is matching. That's a solution. Let's try another one. Done. Okay. Anyone else still writing? Everyone's good? Ahmed's still the only one out. Okay, 4x equals 2y plus 3, and the other equation, negative y plus 2x minus the 2 is equal to 0. What do you want to solve for? What's the easiest one? Y in the bottom, exactly. If you move that negative y to this side, you will have what? 2x minus 2 equals what? Y. You could have solved for x here, but you got to deal with the fraction. I don't want to deal with the fraction. So now take that equation, the top one, the other equation, which is 2x equals 2 times, replace y with 2x minus 2. Oh, that's 4x, the first one, right? Not 2x. Because when I made it, I had a plan in my mind. The x's to cancel out, like, oh, wait a minute, something is not right. So 4x equals 2 times 2x, which is what? 4x minus 2 times 2, which is 4, plus the 3. Solve this. Move all the x's to one side, all the numbers on the opposite side. What's 4x minus 4x? 0. What's negative 4 plus 3? Negative 1. Now, how often we looked in a math book and we saw 0 equals negative 1? Never. Never. This is a false statement. And if it's false, that means what? No solution. Remember, when you're solving two equations by two unknowns, what are you looking for? Where the two lines intersect each other. This one tells you no solution, they'll never intersect. Well, how come two lines don't intersect each other? Why not? They have to be parallel. They must be parallel, otherwise you'll have a solution. I love those problems where you get a false or a true statement because it's a quick way. Not a lot of math to do there. Now, if I change the problem just a hair, the same problem, if I just change a minor thing in that problem, it changes the whole thing. So, for example, if I make this one 4x equals 2y plus 4 instead of 3. And I said, let's change that problem to this. Solve for y here. Y equals what? 2x minus the 2. I took the minus y there, made it plus y. Now come back to the other equation, which is the top one, and replace y with 2x minus 2. (4x) equals 2 times 2x, which is what? 4x minus 4 plus the 4. All the x's on one side. What's 4x minus 4x? What's negative 4 plus 4? That's always a true statement. What does that mean? Same line, infinite solution, yes. When you graph them, the two lines on top of each other. infinite solution. We have an infinite solution. Any point on the line. So instead of just saying infinite solution, a lot of times what we write for a solution, we go x such that, and we just take one of the equations and write it down. And what that means, anything that actually satisfies this one, any x value that's on this equation will also be on the other one. Just write the name of that equation. So we have, sometimes we call that dependent too, right? When they're on top of each other. That's another way the book might say the answer. These are dependent. Yes, they are on top of each other. So that's how substitution works. We solve for one of the variables, plug it in, change it to one equation. If you have, by the way, 3 equations by 3 unknowns, you still can use that method. Each time you do substitution, you shrink it by one variable. So if you start with 3 by 3, if you do substitution, you end up with 2 by 2. Then you do substitution again, you end up with 1 equation by 1 unknown. We'll get to 3 by 3 in the last section here. Right now we're just dealing with 2 equations by 2 unknowns. Another method besides substitution, a lot of people say, I'm not a fan of substitution. It's called the addition method. I like the old names. An old math book, we used to call that elimination by addition. And if you listen to that name, elimination by addition, remember the first one we did today, and I said probably not the best way to do it. What was the first problem we did? This one. Remember that one? Here we go. That's the one we did today. If you listen to the name, it says elimination by addition, which means when you add the 2 equations, we're supposed to do what? Eliminate one of the variables. You have to eliminate one of the variables. If they don't eliminate, it's not good. So let me add them. What's x plus 3x? I'm adding. 4x. What's negative 3y plus 3y? 0, it's gone. What's 6 plus 3? 9. Did I write the right equation? X, 2x. I know I wrote something wrong because I remember the answer. This was a 2 when I copied that. I just wrote the 3 here. Something didn't sound right here because they should give you the same answer regardless what method we use. So what's x equal to here? 3. Is that what we came up with? No, it's 3. Now if I solve it for y, which means grab either equation, doesn't matter which one. I'm picking the top one, no reason. I could have picked the bottom one and replace x with 3. Move the 3 there. 6 minus 3, which is 3, y equals what? Negative 1. So my solution, 3 comma negative 1, and you test that solution. I know that's the answer. I already tested that one, so I'm not going to waste the time on testing it again. But that's my solution. You're supposed to eliminate one of the variables when you add. The problem is, a lot of times when you add them, you don't eliminate the variable. Oh, wait a minute. Something doesn't look right here. Let me try another one. Let's say we have 3x minus 2y equals 4. X plus 3y equals 2. Now if you add them, nothing gets eliminated. Nothing. What's 3x and x when you add them? 4x, right? What's negative 2y plus 3y? Plus y. That's not good. That's why I don't like the new name. It says elimination by addition. It sounds better. It reminds you have to eliminate one of the variables when you add them. That doesn't eliminate anything. So I don't like this. That's not good. It doesn't help me. Okay. If this number was a negative 3, somehow magically this number was a negative 3, what will happen when you add them? The x will disappear, right? So how do we make that number negative 3 without changing the equation? You can't just put a minus 3 because you want to eliminate it. We're going to multiply every single one of these by negative 3. So the first equation is going to stay the same. Here we go. 3x minus 2y equals 4. And this will be what? Negative 3x minus 9y equals what? Negative 6. Now add them. Gone. Perfect. What's negative 2 minus 9? Negative 11y equals what? Negative 2, what is y equal to? 2 over 11. We did that one too early. Remember that one? Where was it? Where'd you go? I know we did that one. Y equals 2 over 11. That's it. Can I get the x value? Sure. Grab either one. Maybe I'll take the bottom equation. No reason. X plus 3 times 2 over 11 is equal to 2. X plus 6 over 11 equals 2. X equals what? 2 minus 6 over 11. The 2 is 2 over 1, or 22 over 11, minus the 6 over 11, and what's x equal to? 16 over 11. Same exact answer. My solution, almost all the new math book, they call this method the addition method. You grab the older books, always elimination by addition. I wish they kept the old name, you know? Let's try another example that we did with the substitution method. We'll do with the elimination method. See if the answer is the same. You'll be surprised how many times I give a problem like this as a solve it using substitution and solve it using the elimination method. Once you solve it in one method, you know what the solution is. Doesn't matter what method you use. And you have people giving you two different answers. With substitution, there's my solution. With the elimination, there's my answer. How can you have two solutions to the same problem? You can't. Regardless what method we use, the solution should be the same. We did this one early too. Oh, plus here. I'm just taking the problem we did early today with substitution. I'm doing with the elimination method. I don't like the way these are looking. So what I might do here, rewrite them. Rewrite this one by bringing the 2y to this side, make it what? 4x minus 2y equals 3. And this one, I'm going to write 2x, I'm going to put them in the right order, minus y, but I'm going to take the minus 2 to the other side. When I do that, that becomes what? A 2. So the first thing I did, reshuffle them. Now what do you want to cancel, x or y? Which one? It's up to you. Y? So I need to make sure that number then must be, one of them has to be what? Plus 2y. If I make this plus 2y, it cancels the minus 2y. How do you make that a plus 2y? Times the whole equation by negative 2. So the first equation, 4x minus 2y equals 3. I'm not touching that. When I multiply by negative 2, what's negative 2 times 2x? Negative 4x. What's negative 2 times negative y? Plus 2y. And that's a negative 4. Now let's add them. Gone, gone. 0 equals negative 1. Again, that's a false statement. That means no solution. That means my lines are what? Lines, I don't know, I have an A there. Are parallel. Parallel lines. We also call them what? Inconsistent last time. Inconsistent when the lines are parallel. That looks like an A, but it's an E. Still looks like an A. Inconsistent. False statement. Let's try one more. This method. So solve (5y minus or 5x minus 3y equals 15 . 7x plus 4y equals 21. I try to give you really ugly numbers. Intentionally, I try to make sure you can't just cancel x. It's not that easy without fraction. Or you can't cancel y. You can't make this number equal to that just by multiplying one equation by a number. So notice I can say, what do you want to cancel here, x or y? What do you want to eliminate? You choose. Y? Okay, I heard y. So let's eliminate y. Well, how do you eliminate y? Good luck making these numbers equal to each other. Y actually was a good choice. Why? Because 1 is minus, 1 is plus. It's got to change the numbers. It's not a big deal because I can multiply this by a minus number. But how would I make the numbers match? Like what? Multiply each one by a different number. I go like what? Yes, swap the coefficient. Multiply this equation by that number, and multiply this equation by that number. That's the quickest way. Flip-flop the numbers. What's 4 times 5? 20x minus 12y. 4 times 15, which is what, 60? 21x plus 12y, 63. Add them. Gone. 41x equals 123. X will be 3 if you divide 123 by 41. Once you know x, you grab either equation, doesn't matter. I pick the top again, no reason. Five times 3, which is what? 15 minus 3y equals 15. Negative 3y equals 0. Y will have to be what? What is 0 divided by negative 3? 0. So your solution here is 3, 0. And if you check it, if you plug it in to see if it works, it does work in both of them. 3 times 5, 15 minus nothing. 15 minus nothing is 15. 7 times 3, 21. 21 plus nothing is 21. So it does work. So that's how the elimination method works. Try both, give them both a fair try, because you'll find out in some cases substitution is really easier than the elimination method. If you have a problem, like I'll just show you the book here, looking at it. Just gotta wait till you finish writing. Okay. If you have a problem like these, notice, I don't know if you can see number 5 here. It says x equals y plus 3, x minus 2y equals 5. What do you think? Which method is better here? X equals y plus 3, that's the first equation. X minus 2y equals 5. Substitution is the better method. Why? Because step number 1 is already done for you. Solve for one of the variables. They did that. So all you got to do, go to this equation, replace x with what? Y plus 3. So if you see a problem like this, substitution is a better choice. A lot of people want to just learn one method and stick with it. There's nothing wrong with it, but learn both. Because in a case like this, x equals 2y plus 1 in this equation, substitution again is the quickest way. If I have 2x plus 3y equals 7, 6x minus y equals 1, I probably go with the elimination method. Because I just got to multiply that the bottom equation by 3, and there goes y. So learn both methods. Practice them both. Okay, so that's the end of that section.